You know why. Okay, so let's look through this real quick. All right. So the average score is a 6 right now, which is actually being held back because a lot of the, that can't be right. There we go. That makes more sense. The average score is a 6, which is actually held back because the first 50 responses, there was like a error with one of the questions. It wasn't grading, so I had to fix that. But let's say that 6 is the real average. That would mean that the overall average for you guys is a 75%, which is really good. That's like exactly what I shoot for when I write quizzes, is I want you guys to score somewhere around a 75% average as a class. I have a feeling that this is going to be a pretty high average quiz, closer to 80%, maybe even over that, especially with this class. You guys are a very strong class. You do really well as, you know, a group. So yeah, I think that this is going to be beneficial for everybody in class for your grades and stuff. So that's good. That's good news. But let's look at these particular questions. So number 1, we have a car driving down a road. What type of energy is that? So that's going to be kinetic energy. This just comes down to a simple definition, essentially. Kinetic energy is the type of energy associated with movement. The word kina is like an old Greek word. I don't know if they use it in the Greek language anymore. I don't know anything about Greek. But kina is Greek for movement. And so the word kinetic energy really translates to energy of movement. Okay. So a car driving down the road, it's moving, that's kinetic energy. A hawk sitting in a tree. This one kind of surprised me that so many people put elastic potential. It is the correct answer is gravitational potential. Okay. So basically what this comes down to is we're talking only about mechanical energy. This is the only type of energy that we're going to discuss in this chapter, because mechanical energy is the energy of like everyday objects. Okay, we're not talking about electrical energy. We're not talking about nuclear energy. We're not talking about chemical energy. We're talking about energy that we can see acting on like physical objects. Does the object fall when it slides off a shelf? Does an object roll down the street? Those are the things that we're talking about. We're talking about those very basic, fundamental changes in motion. And that's that can be described through mechanical energy. There's 2 main types that we're talking about. We're talking about kinetic. Kinetic is one type of mechanical energy, which is the energy things have whenever they are moving. And then there is what we call potential. Okay. There's a couple different types of potential. The type that we're talking about in our class in this chapter is specifically about gravity and height. So the higher something is, the more potential that gravity has for making it fall, right? The higher something is, the faster it will fall whenever it does fall. So that's what we mean whenever we say like gravitational potential. We're just talking about the potential energy something gets as it goes up, because like there's more room for gravity to act on it. That's a type of potential. There is such a thing that exists called elastic potential, which is the type of potential energy gained when a material is either pulled apart or squished together. And it's like the energy that is stored in that deformation because it wants to revert to its original shape. Think about like a rubber band. As you pull a rubber band, it like wants to revert to its normal size. So that would be elastic potential. We are not talking about this. We haven't discussed it. It hasn't. We did mention it in the notes. I did acknowledge that it exists. But the two main things that we're talking about here are kinetic and potential, as in like gravitational potential. We're not talking about rubber bands. We're not talking about this because it's kind of complicated. It has its own like brand of physics. So if you ever see a question that's like asking about different types of energy, essentially the only two types of energy that we're going to talk about, or that might be an answer in this class for this chapter, would be kinetic or potential, like gravitational potential. Anything else is just like a distractor, trying to distract you. Okay. So we're not talking about nuclear energy. We're not talking about elasticity. We're not talking about deforming objects. We're talking about things falling or things moving. All right. So number 3, which object is true about conservation of energy? As we saw in the skate park like simulation, total energy does not change. And most of you got that correct. Most of you said total mechanical does not change. But we saw that as the skateboarder goes up, their potential energy increases and their kinetic decreases, because as you go up, you slow down because some of your kinetic energy is being converted to potential. But then as you go back down the hill, you're speeding up. Your potential is going down because you're going down in the atmosphere, like there's less room for gravity to pull you, and your kinetic goes up because you're moving faster. But it never exceeds the total mechanical, and the total mechanical does not change. So total mechanical does not change. The total amount is always conserved. What is the potential energy of a 10 kilogram mass that is 1 meter above the ground with gravity of 10? Well, potential energy is mass times gravity times height, so you just multiply these 3 numbers together. 10 times 10 is 100, times 1 is 100. 10 times 10 times 1. Very good. Number 5, same type of question, except this time we're asking about kinetic instead of potential. Mass is 0.5. Velocity is 9. So you just take those numbers and plug them in. 1/2 times 1/2 times 9 squared. You could do that in a calculator. 9 squared times 0.5 times 0.5. And there you go. 20.3. All right, and numbers 7 through 8, or 6 through 8, deal with this picture. What is the total mechanical energy at point D? Well, remember, the mechanical energy That's the total. It doesn't change. It's the same everywhere. So we have it at point A, so that's the same at point D. So it's 75, 75, 75. Using the chart above, what is kinetic at point C? So if we happen to know that it's going to be 75 the whole way across because total mechanical does not change, and we're asking about point C, we need to find what kinetic energy is. Remember, mechanical energy, the total, is just the sum of the two parts, which is potential plus kinetic. So if we plug these numbers into this equation, 75 is equal to 35 plus KE. We just solved for kinetic energy, which means we got to subtract 35 from both sides. And that gives you a kinetic energy of 40. Because remember, mechanical is the total. This is the sum of these two things. So if we put these two things together by adding them, it is that. Okay. Number 7. Nope, we already just answered that one. Number 8. What is potential energy at point B? Let's look at point B. Let me get rid of this. All right. So at point B, we know that we have mechanical energy of 75 and kinetic energy of 75. Is there any room for there to be any potential energy left? No. So we know it's 0. If you want to make sure and you want to plug these into the equation, you can do that. Mechanical energy is 75. Potential energy would be unknown because we're assuming we don't. We're just checking to make sure that it does come out to 0. And kinetic energy is 75 as well. Solve for PE. Subtract 75 from both sides. PE equals 0. Okay, so that proves us right. And that is it. Are there any questions about this practice? Any questions? Okay. Let me stop my recording.